Hello everyone, this is the solution for number 64 from our homework. Here's our situation we have on an icy day. You worry about parking a car in your driveway that's on an incline of 12 degrees. Your neighbor's driveway is at 9 degrees and the driveway across the street is 6. So we're trying to figure out which one, if any, is safe to park on. So we know that the coefficient of static friction between the tires and the ice is 0.15. So we know mu. And that's pretty much it. So first off, we want to start off with a picture of our scenario. Don't laugh at my car. And we're going to be solving for which angle is safe. So instead of going through each one, we can kind of just solve for that critical angle of what is going to be safe. So ideally, we want to be drawing a force diagram where all the forces are equal because we don't want our car to slide on the ice, which actually happens to me in real life. I parked on the driveway and the snow started to melt, therefore changing the mu, and my car wound up in the street. So here's our force diagram. We see that we do have to break up gravity into x and y components, nothing new for us. So I got my FGY, FGX, and I don't want my car to move, so that's because the normal force is equal to the y component of gravity, and friction up the hill is equal to the component of gravity down the hill. So next I want to start with a net force equation. So F equals ma, but I do need to identify what forces I am concerned with here. So I'm concerned with force due to gravity in x direction down the hill, and hopefully, if I park correctly, that will equal to friction up the hill. So this is my starting point. Now, we could kind of continue this and say that, in an ideal situation for this angle, the acceleration would be 0, making this whole term drop off. But I'm going to go through with all the variables so that we understand and can use this equation even if the acceleration wasn't 0. So here we go. So FGX, what do we know about FGX? It's equal to force of friction. Well, how can we solve for this? Well, if we had the mass, we could then calculate force due to gravity because we know Fg equals mg. Oh, and my angle that I'm looking for is right there. So Fg of x is going to be equal to sine theta times gravity, force due to gravity. So and I'm just going to kind of continue with that part of the equation since we're talking about it. Since we know that force due to gravity is mass times acceleration due to gravity, we can go one step further and say sine theta is equal to mg. Cool. Well, what about friction? Well, friction, right, over here, what is that equal to? Is there a way we could find that out? Well, we know that from the lab for friction, it's the fun equation. So force of friction equals mu normal force. So we could say, okay, we're starting to get someplace because mu, we actually have that value. And that all equals mass times acceleration. So just a little tip or trick, anytime that you're not provided with all the variables, chances are something's going to be canceled out. So this is where that everybody brought mass to the party scenario is going to start to come into play. So normal force from our force diagram is equal to FGY. So to get FGY, that would be cosine theta times Fg, which is our hypotenuse, equals mass times acceleration. I can go one step further and say FG equals MG. And we now see that everybody brought mass to the party. So we could take mass from everybody. And now we can actually say that acceleration is 0. So that would be a scenario where our forces are equal. So if we rearrange and move this term to the other side of the equation, I would end up with cosine theta g from here. Right, and then I'm going to add this to the other side. And I'm solving for an angle, or sorry, forgot about the gravity party. Everybody brought acceleration due to gravity to the party. So mu cosine theta equals sine theta. If I divide cosine theta over, I get sine theta over cosine theta, which is the same as saying tan theta. And now I'm looking for an angle. I have my mu value from the beginning. Yep. Plug that into a calculator, and I get an angle of 8.5 degrees. So that's the boundary. If I park at 8.5 and anything less, the forces will be equal, but anything else greater than that angle is not safe. So I cannot park on the neighbor's driveway or your driveway. So I have to park across the street in the angle that's less than 8.5.